ఆచార్య తెచ్చుకుంటాం. Come this side, Varun and Sai. Sit in front of me. ఇక్కడ ఈ కార్బన్ అండ్ ఇట్స్ కాంపౌండ్స్ మనకి కొంచెం ఏమంటారు డైరెక్ట్ క్వశ్చన్స్ అడగట్లేదు కదమ్మా, ఇండైరెక్ట్ క్వశ్చన్స్ అడుగుతున్నారు. సో షెల్ వి డూ PYQs? లాంగ్ ఆన్సర్ క్వశ్చన్స్ రావట్లేదు, వస్తున్నాయి లాంగ్ ఆన్సర్ క్వశ్చన్స్. యు ఆర్ గెటింగ్ ఓన్లీ 2 marks as 3 marks. But lengthy chapter. Draw this one. We will start after coming with Swati. Write the activity series. You have extra pen, Sai and Varun? Who? Oh. No more. Come this side, all of you come here. Yes. So as we discussed yesterday, copper does not react with the
diluted hydrochloric acid.
dilute hydrochloric acids. We know that high reactive metals can replace the
Low reactive.
less reactive or low reactive metals. Get my mobile, Amma. Ask to sir. Mm. Mom is asking phone. Here. Can you write the configuration of phosphorus? Phosphorus.
Two comma 8,1.
What is phosphorus atomic number?
18.
18 is argon. Eighteen is argon. It's wrong.
Sixteen. 2,8,6.
Atomic number is 15.
2,8,4.
Fluorine. Fluorine.
2,7.
Chlorine.
Comma 8,7.
2 comma
8,7.
sulfur.
2,4. 2,8,4.
Wrong. What is sulfur atomic number?
7.
Sulfur is 16 kada. Before chlorine sulfur comes.
Tetravalent ఎట్లా tetravalent 2,8,6. Tetravalent
The six, how the 6 electrons are distributed?
టెట్రావాలెంట్ అంటే 4 వ్యాలెన్స్ ఉన్నదాన్ని టెట్రావాలెంట్ అంటారు కదా. కార్బన్కి సల్ఫర్కి టెట్రావాలెన్సీ ఉంటుంది. దీనికి ఇక టెట్రావాలెన్స్ 2 ఉంది వ్యాలెన్స్.
Give me that pen, Varun. Means it is distributed in the orbitals like this: 1s2, 2s2, 2p6, 3s2, 3p, 2, 4, 10, 12. Okay, 4, no? Here in the third shell there is d orbital also. D orbital starts from third shell. 3d 0. So what will happen? This is the configuration of ground cell. Okay. Okay, like this. This is configuration of ground state. When any other atom comes near to sulfur, it will get energy and will get excited. So what will happen? This paired electron will jump into the empty 3d orbital. Okay, first case is like this. As you told, it will give the tetravalency. There are 4 unpaired electrons. Next, if you see here, another possibility is also there. In the next step, this unpaired orbital of S will jump into the 3D. So that this is second case. It can form 6 bonds as well as 4 bonds. Okay, according to the situation. Go according to the atomic number. Don't go which you have the knowledge on it. Configuration especially. Atomic number, based on atomic number you try it. Next. Potassium.
Two, 8, 9, 8, 1. 2, 8, 1.
What is the potassium atomic number?
90.
Calcium?
20.
Configuration?
Correct. 2, 8, 1. Calcium 2, 8, 2.
2. Yes. Aluminium?
13. 8, 3.
Who? Aluminium. 2,
8, 3.
Yes, if you see the electronic configurations, okay, the atom which is having stable, to get the octet configuration, okay, why aluminium is showing +3 configuration?
because it needs to lose three electrons
To attain the octet conjugate, say like this, to attain the
to attain the octet state. It need to lose these three electrons. So
gaining of 5 electrons is difficult to aluminum. That's why it will
lose
lose the 3 electrons. If you see in case of calcium, why calcium always loses plus 2?
because to attain its octet state, it needs to lose two electrons.
2 electrons. If you see in case of calcium. In case of potassium, why always potassium loses only 1 electron? Same.
Because to fulfill it octet state, it needs to lose one electron.
1 electron like that. So which have a completely filled valence shell, show little chemical activity, and they attain a completely filled valence shell either by losing or either by gaining. If you see for chlorine 7 are
It
there,
loses one, gains one electron.
so it will never lose electrons, always it gains electrons, right? Why is sodium kept immersed in kerosene oil?
Because it reacts vigorously with the air and the moisture in the air. So to make a non-reactive environment, sodium is kept in the kerosene.
Which could cause fire or explosion. Hmm? To prevent it
Like the biology of
reacting with,
chemistry and corrosion.
we'll finish this one Amma today. We'll once discuss, then you can go for bio. Okay. Today you can do bio or physics. Hmm? To prevent it from reacting with oxygen and carbon dioxide, moisture in the air. 3 reasons. We are keeping kerosene in the, sodium in the kerosene. Write the equations of iron with steam, Amma. Write the reaction of iron with steam. Write the reaction of iron with
Fe2O3.xh2. Or Fe3O. Fe3O.
ferric oxide only it will form. Fe3O4.
When will Fe2O3.x2 form?
Fe2
O3.xh2.
when it reacts with water, I think it is giving a steam, no?
Moisture.
Moisture.
H2 only.
Fe3O4 it is ferric oxide. Ferric means here iron is losing 3 electrons. Iron is losing 3 electrons. Fe3 ferric. Fe3O4. Write the reaction of calcium and potassium with water.
Like this.
Hmm?
ఇవి హైడ్రోజన్ ఇవే రాష్ట్రం.
Calcium and potassium. Right, once again.
CaOH plus H2, KOH plus H2.
You wrote calcium wrong. Check it once. You wrote with calcium wrong.
COH.
Just now I discussed that calcium always loses 2 electrons. You will not get mark. CaOH if you write. Which gas is produced when dilute? Which gas is produced when dilute hydrochloric acid is added to the reactive metal? Write the chemical reaction.
H2.
Hmm. You can write zinc, iron, any metal you can write. Okay. What would you observe when zinc is added to a solution of iron sulfate? Here reactivity based question. Huh? Which is more reactive? Here
Is zinc.
zinc sulfate is needed.
Displace.
Mom, can I do cell?
So here when you add
Mom, can I write cell?
the solution turns colorless actually. Okay.
Yes.
Solution turns
Colorless. Because zinc sulfate color is white, transparent.
uh, a gray precipitate of iron forms. Can you say the properties of ionic compounds?
Solid in nature, good solvent in water, conduct electricity when insoluble, when
Say like
when
this
dissolved.
physical nature, what is that one? Melting and boiling points.
They have high melting and boiling points.
Mom, can I read?
Around
They have
Around-
they have crystal structure.
around how much do they have?
And,
Approximately, not exact values. Approximately.
over 1000 degrees.
Ah. Like that, because they will give in the options sometimes above 1000. Solubility.
When they conduct electricity when dissolved in water, they are good solvent in water, and they do not dissolve in kerosene and other
Gases. Mm. Soluble in water but insoluble in kerosene and petrol. Physical appearance, how do they look?
solid crystals.
Why they are hard?
Because of the strong bond and electrocovalent bond. Because of the ionic bond.
They will give like this: the strong force of attraction between the positive and negative ions, Na plus Cl minus. There is a strong force of attraction between this positively charged ion, negatively charged anion. Due to that, you select that option. Hmm? And they are generally brittle. That means we can break into pieces when pressure is applied. Hmm? What about conductivity?
They conduct electricity when dissolved in water.
Hmm?
They conduct electricity when dissolved in water.
Where, when in water, in solid state, in solid state,
They do not conduct electricity.
why?
They do not contain charge carriers or ions.
Because there are no ions itself. Hmm? Sit here. In molten state, do they conduct electricity?
Yes.
Hmm? Why?
Contain ions, charge carriers.
If the option is that one, don't select that. In case of water, you can select that option. In case of solids, there is no conduction of electricity. In case of molten state, select the option like this. Okay. Since the electrostatic force of attraction between the oppositely charged ions overcome due to the heat. Select this option. Okay. That is also correct only. But as per the textbook, due to heat, that attraction will overcome. That's why they conduct the electricity in the molten state. That's why ions can move freely and conduct the electricity. Write the electron dot structure for sodium, oxygen, and magnesium. Sodium,
So,
oxygen, and magnesium. Show the formation of sodium oxide and magnesium oxide by the transfer of electrons. Show the formation of sodium oxide, magnesium oxide, transfer of electrons.
ఇట్లా మనం 2n7
సోడియంని కింద రాసుకోవచ్చు కదా, కన్ఫ్యూజ్ లేకోకుండా ఇటు పక్కన కింద రాసుకుంటే ఇలా ట్రాన్స్ఫర్ చేయొచ్చు. దట్ ఈజ్ ఆల్సో కరెక్ట్ ఓన్లీ. అండ్ మెగ్నీషియం ఆక్సైడ్, మెగ్నీషియం ఆక్సైడ్. They have given electrons, no? So you should show with the plus charge here. They have donated, no? That you can show like this. Here oxygen you should write as 8 electrons. Like this you should. Hmm? What are the ions present in these compounds? What are the ions present in these compounds?
And because magnesium is using 2 electrons.
మెటలర్జీ చెప్తాం నెక్స్ట్ టాపిక్.
No, I'm asking what are the ions present in these compounds?
Mg plus 2.
Where are you getting so confused? Mg plus 2 and Na plus. So, if you see the extracting metals, okay, metals low in reactivity series are very unreactive, as we know. Can you name some metals? Those are unreactive.
Gold, silver, mercury.
Yes. The oxides of these metals can be reduced actually to metals by heating alone. When you do just that oxides of metals heating, okay, we can reduce that impurity. For example, if you take cinnabar, cinnabar. Hmm? What is cinnabar formula, Supreet?
HGS, mercury sulfide.
Hmm. It is a ore of,
Mercury.
when it is heated in air, it first convert into the HgO. Okay, and that mercuric oxide is then reduced to mercury on heating. First simple one is heating. It will convert into oxides. Okay. After further heating, that oxide will convert into the metal. Okay. And similarly, copper also. Okay. Can you write the reaction of copper, Amma? Cuprous sulfide, which is present as sulfur is impurity. The formula itself, chemical formula, you wrote wrong, Supreet.
CUS.
Cu2S. Cu2S. After further, what will happen? You are having a copper sulfide with that only. Supreet, show me the reaction. You should write here copper sulfide along with that. You are heating along with that impurity. Then it will give copper. You did not write this Cu2S. You also, along with this CuO, you will have this impurity also. On further heating, plus Cu2S heating. It will go as sulfur dioxide, no? Next. This is in case of low activity series. What we are doing, Subrit, in low activity series?
We are reducing them by heating.
Heating. First of all, it will react with the oxygen which is present in the air. It will convert into oxide. That oxides of metals on further heating, it will eliminate as sulfur dioxide. Okay. Don't eliminate oxygen here. Next. This is a middle of the activity series, extracting metals in the middle activity series. Can you name some middle activity series metals?
Iron.
Zinc, lead, copper. All these are moderately reactive. All these are moderately reactive, not so reactive, not low reactive. They are moderate. These are usually present as sulfides or carbonates. Okay, sulfides are carbonates. So this is it is easier to obtain a metal from its oxide, no, compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides first. How will you convert that one? Heating only. That is heating. Okay. So the sulfide ores are converted into oxides by heating strongly in the presence of excess of air. This heating process in excess of air is called, that method is
Calcination.
Roasting.
roasting. It is roasting. In the excess of air, it is taking the oxygen and they are converting into oxides. That is called as roasting. Okay. So The carbonate ores are changed into oxides by heating strongly limited
ఇది
air.
వచ్చేస్తుంది మనం రోస్టింగ్ ఏమో సల్ఫైడ్స్కి, క్యాల్షినేషన్ ఏమో కార్బోనేట్స్కి. మిడిల్ రియాక్టివ్, మోడరేట్లీ రియాక్టివ్ మెటల్స్ ఆర్ ఫౌండ్ ఇన్ carbonate ore and sulfide ore. Like zinc is found in sulfide ore and also in carbonate ore.
Mm.
Roasting process అయిపోయినాక they use a
Calcination.
reducing agent which is coke, but for high reactive metal they do not use a reducing agent. They use a reducing agent coke and remove the impurities, and finally the pure metal is found. But low reactive metals are found only in sulfides. They do roasting. High reactive metals are found are not found in both. They are found in this state. To remove the impurities, they do electrolysis.
What is calcination, Swati?
Heating the metal in absence of oxygen.
In presence of low oxygen.
Limited, not absent. Limited amount.
Without oxygen burning on it does not take.
Write the zinc impurity reactions.
Carbonate or sulfide.
Sulfide ore and carbonate both.
ఇది ఆక్సిజన్ నేచురల్ ఆక్సిజన్ కాదు, మనము రోస్టింగ్ ఇస్తాం ప్రొవైడ్ చేసే ఆక్సిజన్.
Excess of air we are telling, no. In the nature, how excess of oxygen is present? No. Intentionally we have to supply that, no. We are mentioning here limited, excess means definitely we should give, no.
It will form ZNO and SO2.
Oh. Definitely sulfur dioxide, as you have seen in case of copper.
Now here ZNO plus a reducing agent we take, and it eliminates as Zn plus CO2.
Mm.
Pure.
In case of carbonate, it will not eliminate as CO2, right?
Carbon monoxide.
Monoxide, it will eliminate as carbon monoxide.
CO3.
You are not having two oxygens, no, here. Swati? This ZNO is there, no? ZNO on supply of coke. Coke means carbon. Right, carbon here. C plus C. So it will
Zn plus carbon
monoxide, not CO2. Okay. Yeah, whatever you write the matter, they will not accept. But reaction is important in chemistry. You keep the reactions in the square bracket. Gases you should show upward arrow.
And liberated from upward arrow. Gas are being liberated and symbol. Like the gas and state rala.
You can write gas. Who is acting here reducing agent discipline? Carbon. Okay. You are already familiar with the process of the oxidation and the reduction, no? What is oxidation and reduction? Addition of oxygen or removal of hydrogen. Removal of hydrogen. What is reduction? Addition of hydrogen and removal of oxygen. So here whatever this metals from their compounds are there, they are reduction process, right? Reduction. We are removing. What we are removing here? Oxygen. reduction process only. So, so if we can also, besides using carbon to reduce metal oxides, metals, so sometimes displacement reactions can be also used. Okay, so the highly reactive metals such as sodium, calcium, aluminum, they are acting as reducing agents. They can displace the metals lower activity series like magnesium oxide with aluminum powder. Okay, can you write that reaction? Magnesium. In textbook they have given manganese oxide.
Magnesium oxide with aluminum.
Aluminum powder, you can write. What is manganese oxide formula, Supreet?
MnO3.
Mn plus 2, amma, stable oxidation state. Manganese is plus 2.
Al2O3 plus Mn.
Can you write balanced reaction to that?
ఇంకేమనుకో హార్డ్ పనిష్మెంట్ అంటే ఓకే పనిష్మెంట్ అని పెడతాను.
Manganese oxide. Leave it.
పొద్దున్నే చదువుకున్నాను. పేరు కూడా హార్డ్ పనిష్మెంట్ అని పెట్టుకోండి ఎవరు.
ఇన్ని పనిష్మెంట్ తీసుకుంటున్నాడు.
పెడతారు డిలీట్ చేసి పెడతారు. పొద్దున అడుగుతారు.
He likes you so much. అమ్మ రియాక్షన్ తప్పు రాసేవరా. మ్యాంగనీస్ ఆక్సైడ్ MnO2. MnO2. ఓకే, MnO2ని మనము ఎలా ఆక్సిడైజ్ చేస్తున్నాం? విత్ అల్యూమినియం పౌడర్. Al2O3. ఓకే, గుడ్. కెన్ యూ బ్యాలెన్స్ దట్ రియాక్షన్? Did you balance? Here heat also will release, exothermic reaction.
Yes, balance 3MnO2 plus 4Al is equal to 2Al2O3 plus 3Mn.
Can you identify in this which is oxidizing and which is reducing?
MnO2 is reduced to Mn. Al is oxidized to Al2O3.
Who is oxidizing agent? Who is reducing agent here?
MnO2 is oxidizing agent, Al is reducing.
Most important reaction, okay, remember. Yes, these displacement reactions are very exothermic, highly exothermic reactions, okay. The amount of heat which is evolved is so large actually that metals are produced in the molten state. In fact, the reaction of iron 3, that is Fe2O3, as you told, Fe2O3
With aluminum.
with aluminum is used to join railway tracks and cracked machine parts. This reaction is called as thermit reaction. What is thermit reaction, Amma? Can you write thermit reaction?
Fe2O3 plus Al gives rise to Al2O3 plus Fe. This is
Heat,
displacement result.
exothermic
It
we are
evolves,
telling, no?
It evolves so much of heat that the metals formed are in molten state and it is used in joining the railway tracks.
Balance that reaction, Supreet. Without balance, the reaction will not be accepted. Definitely you will miss the mark. At least half mark they will cut.
Fe2O3 plus 2Al gives rise to Al2O3 plus 2Fe.
Yes, next. With the top of the activity series, those are which are highly reactive. Okay. The metals which are high up in the reactive series, very reactive. They can't be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium and magnesium. As we have seen earlier, okay, on heating, carbon is reducing the metal oxides. But here, sodium oxide, magnesium oxide, aluminum oxide, highly reactive metals cannot be reduced with the coke, with the carbon. So what we should do, this is because these metals have the more affinity for oxygen than carbon. కార్బన్తో కంటే ఆక్సిజన్తో ఎఫినిటీ ఎక్కువ ఉంటుంది ఇక్కడ. ఓకే, సో these metals are obtained by electrolytic reduction. How we are getting a electrolytic reduction? So sodium, magnesium, calcium are obtained by the electrolysis of their molten chlorides. Molten chlorides. Sodium chloride, calcium chloride, aluminum chloride. Like this we take that metals are deposited at the cathode. Okay, can you draw the reaction of the electrolytic refining of copper? You have the in intermediate metallurgy. Cathode means here negatively charged electrode. The metals are deposited at the cathode, whereas chlorine is liberated at the anode. Copper I am saying, no? So,
CuCl లా ఉంది అమ్మ. CuCl లా ఉంది. CuCl కాపర్ క్లోరైడ్ తీసుకున్న కాపర్ క్లోరైడ్.
CuCl2.
CuCl2 का अगर बोला Cu వెళ్తా. Cu deposits to
cathode.
Cathode because it's positively charged. And Cl2 is negatively charged. It deposits to positively charged anode.
Chlorine is liberated at anode.
Yes.
Impurity mud will be
Anode, near anode.
ఇక్కడ వస్తుంది, యానోడ్ దగ్గర వస్తుంది.
అంటే క్యాథోడ్ ఇక్కడ ఇది క్యాథోడ్ ఇస్ ప్యూర్ మెటల్.
అవును,
ప్యూర్ మెటల్. దిస్ ఇస్ ఇంప్యూర్ మెటల్.
ఇంప్యూర్ మెటల్.
ఇంప్యూర్ మెటల్.
ఈ ఇంప్యూరిటీస్ ఇక్కడ కిందికి పడిపోతాయి.
ఇంప్యూరిటీస్ కిందికి పడిపోతాయి. ప్లస్ దీంట్లో ఉన్న Cl2 యానోడ్ దగ్గర
గ్యాస్ గా బయటికి లిబరేట్ అవుతుంది.
Cl2 గ్యాస్ ఇక్కడికి
Cl+2 అయాన్స్ ఇటు వెళ్ళేసి ఇక్కడ దీని మీద డిపాజిట్ అవుతాయి. Cu. ఓకే, CuCl2 కదా, అంటే ఈ క్లోరిన్ Cl మైనస్గా వెళ్ళిపోయినప్పుడు ఇక్కడ Cu దేనిగా ఉంటుంది, +2గా ఉంటుంది. అర్థమైందరా స్వాతి? ఓకే, సో సిమిలర్లీ అల్యూమినియం ఈజ్ ఆల్సో obtained by the electrolytic reduction. Okay, so metals produced by various reduction process described above are not very pure actually. So they contain the impurities also, which must be removed by the pure metals by using the electrolytic refining. So many metals such as copper, zinc, tin, nickel, silver, gold, etc. all are refined by the electrolytically. Okay, so in this process the impurity metal is made the anode and the strip of the pure metal is made at the cathode. You remember this one, they may ask you. Okay, at the cathode what you are getting? Pure metal. And at the anode what you are getting? Impurities. A solution of metal salt is used as electrolyte. What we are using as electrolyte here? Solution of metal salt that they have shown in this figure. If you pass the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte Equivalent amount of pure metal from the electrolyte is deposited at the cathode. So soluble impurities go into the solution, whereas the insoluble impurities settle down the bottom of the anode. Okay, that is called as anode mud. Okay, you say the what is ore, Amma?
Ore is a mineral which contain most of the parties in the world.
Huh? What is ore?
An ore is a mineral in which most of its part is metal.
It is a naturally occurring rock, okay, sediment that contains valuable minerals.
Ore is a mineral which contains
High.
mostly more than 75% metal ఉంటుందంట ఓర్ కూడా ఒక మినరల్ all ores are minerals but all minerals are not ores.
What is gang?
The impurities.
Unwanted material. Define mineral. Swati.
Meaning of mineral, a solid, naturally occurring inorganic substance.
Define mineral, Swati.
Mineral is a naturally occurring organic material.
Name two metals which are found in nature in the free state.
Gold, silver,
Gold, silver, platinum.
What chemical process is used to obtain a metal from its oxide?
Calcination. Sorry, burning. Burning, roast. Reducing or reducing with a reducing agent.
Process, reduction only, no?
Reduction.
Say about the corrosion, Subbu.
Corrosion is a process in which the metal reacts.
Once
with
you
the
go through the textbook, you need not to be, there is no questions in that. Explain that corrosion once after reading the textbook. You also saw it. We'll do the carbonates compounds previous year questions only, Amma, because you are not getting questions same as they have given examples. More beyond that they are asking. So once PYQs if we do, then think you know already naming everything, no? From the UPAC name, definitely one question you will get as 2 marks. Here Tanish wrote dictation, he got 10 out of 10. Instead of dictation, learn question answers. Learn question answers from the chapter.
Oh my God.
Varun got 10 out of 10 in the English dictation and in the maths 10 out of 10. Do Telugu reading also in the morning. Telugu dictation also you write. Okay.
Okay.
Say about the corrosion.
The silver reacts with the air in the air and it forms a black color layer which is silver especially reacts with the sulfur dioxide and it forms a layer of Ag2S which is black in color which corrodes the metal and weakens the metal and decreases tensile strength. Copper reacts with the moist carbon dioxide and it forms CuCO3 layer which is green in color, which is also known as patina. This process is known as tarnishing. By this, the metal loses its luster and it becomes and its tensile strength. In case of iron, attains yeah, when iron reacts with moist water, OH2, it forms a layer of iron oxide, which is brown color, reddish brown flaky substance, which weakens the metal, which corrodes the metal,
Which is called
which is called iron oxide Fe2O3.xH2,
rust.
rust. In this process, the corrosion in iron is known as rusting.
How do you prevent corrosion? Once go through the textbook points. Here, Sai got 10 out of 10 marks. Every day you should write the writing part. Hindi, English, Telugu. All you should write. 3 subjects. One paragraph every day you need to write in the morning. 10 out of 10 marks. Four out of 5. I think bio you can do on your own. If you want a chapter wise any revision, I can do it. No problem. But next I should start physics. Yes. How do you prevent
At many ways, galvanization, anodizing, painting,
chrome blasting, chrome plating, sorry.
plating,
Oiling,
alloying,
greasing.
alloying.
In the galvanization, what do you coat?
Zinc coat.
The galvanized article is protected against rusting, no?
Yes.
Even if the zinc coating is broken. Why? Can you say the reason?
Even if the zinc coating is broken.
Can you reason this out? Because it is reacting. Displacement takes place. No? There.
I did not understand question.
Even we are doing galvanization of protecting the steel, iron. We are galvanizing the articles.
Yes.
So we are just preventing the rusting, coating with the layer of the zinc. The galvanized article is protected against rusting if the zinc coating is broken.
Because when this zinc reacts with the iron, the zinc displaces iron. So zinc does not corrode, so it's being protected even though the layer is broken.
Did you get this point, sir? Hmm? So best method among all these is alloy. Okay. So iron is the most widely used metal, but it is never used. It's a pure state. We never use it.
It's pure state. It's very soft. When
This is
0.005% of carbon is added, it becomes very hard.
Because pure iron is very soft, stretches easily when it is hot, but it is mixed with a small amount of carbon, 0.05%. Okay, it becomes hard and strong, and it is also mixed with nickel and chromium. Nickel and chromium.
From 1 hour and loading.
Yes. The properties any metal can change its mixed with some other substances. So the substance added may be a metal or a non-metal. An alloy is a homologous mixture two or more metals or a metal and a non-metal. Okay. This is by first melting the primary metal, then it will dissolve other metals.
which is which is which is a mixture of metal and metal or a metal or a non-metal.
What are alloys? It is a metallic substance. We are combining here. We are saying no, combining two or more elements. Either it may be a metal or a non-metal or both are metals. Yes. You wrote dictation, no? Got 11.5 marks out of 12 in the dictation. Again in English.
I did got the scale.
4 marks out of 5. సో కొంచెం తెలుగు ఇంప్రూవ్ అయ్యావు మనీష్, కొంచెం పర్లేదు. ఇంకా కొంచెం మంచిగా రీడింగ్ చేయి, రోజు ఒక పారాగ్రాఫ్ రీడింగ్ చేయి. అందులో ఉండే హార్డ్ వర్డ్స్ అడుగుతుండు. Which metals don't corrode easily? Swati?
Low reactive metals not easily.
Gold and
Silver.
platinum. If one of the material is mercury, or that alloy is called as amalgam. The electrical conductivity and melting points of a alloy is less than that of the pure metals. ప్యూర్ మెటల్ కంటే వీటిది తక్కువ ఉంటుంది. ఓకే, ఎలక్ట్రికల్ కండక్టివిటీ అండ్ మెల్టింగ్ పాయింట్ ఆఫ్ దట్ alloys is less than that of the pure metals. Suppose brass ఉంది, it is a alloy of Suprit brass.
Brass is alloy of copper, tin, copper, zinc, copper and zinc.
Copper and zinc. Bronze,
Copper and tin.
not good conductors of electricity, whereas copper is a good conductor of electricity. Okay, so we are using copper is for making electrical circuits. So solder,
lead tin.
hmm?
Lead and tin.
lead and tin. It is having low melting point. That is where we use this one, solder.
Solid.
Where we use this one?
It is used in soldering process. Wires, joining the wires. We call it soldering.
వెల్డింగ్ ఎలక్ట్రికల్ వైర్స్ రెండింటిని జాయింట్ చేయడానికి మనము వాడతాం కదా. ఓకే, నెక్స్ట్ అట్ వాట్ టైమ్ విల్ యూ కమ్ సుప్రీత్? స్వాతి
10:30.
So I'll discuss the carbon and its compounds, soaps, detergents ones, that missile formation. Okay, some reactions I wanted to discuss in this, that is addition reactions, substitution reactions. This IUPAC naming we will go through the PYQs only, because there are chances of getting beyond your syllabus you are getting. Once we'll go through the allotropes of carbon. Okay, you imagine that it is a matter of 1 hour. Okay, then if you want, Swati, I will discuss the chapter wise bio also in these 2 days. We'll go through the physics. ఫిజిక్స్ నాన్న చేపిస్తున్నాడంట కదమ్మా. చేసావా నిన్న మొన్న ఏమైనా చేసావా ఫిజిక్స్?
ఈరోజు లైవ్ కొంచెం చేసిన, ఇంకొంచెం టైం ఎక్కువ ఉంటుంది కంప్లీట్.
Okay, we will wind up the class. Will be continued at 10 o'clock, 10 to 11 or 12. Okay, till 12 o'clock I will be available. Nana, I need some rest. ఏమైపోతుందంటే మీ దగ్గరే 2 దాకా ఉంటుంటే మళ్ళీ వచ్చి ఇక్కడ అవ్వట్లేదు.
Okay.
So you can go after 12 o'clock. Otherwise you can solve the sample papers sitting on your own. ఏదైనా డౌట్ ఉంటే డిస్కస్ చేద్దాం.